Hi friends, welcome to our lesson. I'm Mrs. Gradney, and today we'll be using our place value understanding to multiply 3-digit numbers by 1-digit numbers using the standard algorithm. Here's what you'll need for our lesson today. Let's get started. Let's read this expression together. 6 times 162. We can interpret this as 6 groups of 162. So pause the video now and represent 6 groups of 162 using place value discs on the place value chart. Regroup if necessary and find the product. Then come back and we'll compare our work. Welcome back. Did you need to regroup? I found we did need to regroup. At first, on my place value chart, I had 6 hundreds, 36 tens, and 12 ones. And I regrouped 10 ones for 1 10 and 30 tens for 3 hundreds. So my answer is 9 hundreds, 7 tens, 2 ones, or 972. Is that what you got? Great job. Now that was a lot of discs to draw and keep track of. So let's find a more efficient way to express the answer. And we'll use our work in the place value chart to help. Let's write the expression vertically and use the algorithm. Remember, because of the commutative property, we can record the factors in either order. So when we're multiplying with the algorithm, we typically record the larger factor on top. So 162 times 6. Now, tell me what happened in the ones column of our place value chart. Pause the video to explain. In the ones column, we multiplied 6 times 2 ones to get 12 ones. Then we regrouped 10 ones to make 1 10, and we're left with 2 ones. Here's how we can record what we just said in the algorithm. We can record the regrouped 10 on the line under the tens column, and the ones we still have in the ones place. Look, we still have the number 12. We said 6 times 2 ones is 12 ones, and we can still see the 12 here. Now, tell me what happened in the tens column of our place value chart. Pause the video to explain. In the tens column, we multiplied 6 times 6 tens and got 36 tens. We regrouped or bundled 30 tens for 3 hundreds, and we're left with 6 tens. But we also had the 10 that we regrouped from the ones. So 36 tens plus the 1 10 is 37 tens, which is 3 hundreds, 7 tens. Watch how we can record this in the algorithm. We can record the 3 regrouped hundreds on the line in the hundreds column, and then we can record the tens we still have in the tens place, 7. So we see that 37 tens. Now, what about this 1 here? What did we do with that? This 1 stands for 110, which we know because it's in the tens column. And we added it in with the 36 tens. 6 times 6 tens is 36 tens, plus this 1 10 that we regrouped from the ones is 37 tens. And we can see the 37 tens here as 3 hundreds, 7 tens. So since we used the 110, let's cross it out. Now let's look at the hundreds. Tell me what happened in the hundreds column on our place value chart. Pause the video to explain. In the hundreds column, we had 6 times 100, which equals 6 hundreds, plus the 3 hundreds we regrouped from the tens, which is 9 hundreds. In the algorithm, we can record it like this. 6 groups of 100 is 6 hundreds, plus these 3 hundreds that we regrouped from the tens is 9 hundreds. Since we have no other numbers to multiply, we can just write down the 9 in the product and cross off the 3 since we added it in already. So what's the product? 972. Does it match what we got in the place value chart? It sure does. Let's try another one. Read the problem with me. 237 times 5. Now pause the video and solve the problem using partial products, recording each of the partial products below the problem, like you learned in the previous lesson, and then come back and we'll compare our work. Welcome back. Did you find the product to be 1,185 like I did? If not, pause the video, check your work with mine, and see if you can find your mistake. Okay, now let's solve the same problem using the standard algorithm. So let's rewrite the problem vertically right beside our partial products way. Now, starting in the ones column, what do? We multiply 5 times 7 ones and get 35 ones. How did we record 35 ones in our partial products? Pause the video to explain. To record 35 ones in our partial products, we recorded the 3 in the tens column and the 5 in the ones column on the same line. Let's record 3 tens, 5 ones in the standard algorithm. What do you notice about this recording? Pause the video to talk out what you notice. You may have noticed that the 3 tens on the line is still in the tens place, just like with the partial products. And the 5 ones is in the ones place, so we're still showing 35 ones. When we add the partial products together, the 3 tens will be added in with the other tens. And here, the 3 tens on the line means it will be added to the product as we go. Now, moving to the tens column, what do we do next? Next, we multiply 5 times 3 tens, and we get 15 tens. Where do we see 15 tens in our partial products? We recorded 15 tens as 150 on the second line in our partial products. For the standard algorithm, we need to add in these 3 tens. So 15 tens plus 3 tens is what? 18 tens. We can record 18 tens like this. And remember to scratch out the 3 tens because we already added them in. How does what I just wrote represent 18 tens? 18 tens is equal to 108 tens. This 1 in the hundreds place represents the 100 we regrouped, and this 8 represents the 8 tens we still have. And we can still see the 18 tens here. Now, what do we do next? Next, we multiply 5 times 2 hundreds to get 10 hundreds. Where do we see 10 hundreds in our partial products? 10 hundreds is the same as 1,000, and we see that on the third line in our partial products. How will we record this in the algorithm? In the algorithm, we have to add the 100 that's on the line to make 11 hundreds. And because there are no more numbers to multiply, we can just record 11 hundreds directly in the product. And remember to cross off that 100 since we already added it. So what's the product? The product is 1,185. Look back at the work we did when we solved using partial products. What was the product then? The product was 1,185. It's the same. So even though our methods were different, we came up with the same product. What are the advantages of using the algorithm? Take a moment to reflect on that, and then we'll talk about it. You may be thinking that when we use the algorithm, we record our answer all on one line. Or maybe you thought the algorithm is nice because we're doing all of the calculations in fewer steps. Great thinking. Let's apply our understanding now to solve a word problem. We'll use the RDW process to help us understand the problem. And so let's start by reading the problem together. Ready? Read. Shane measured 457 milliliters of water in a beaker. Olga measured 3 times as much water. How much water did they measure altogether? Now pause the video and draw a tape diagram to represent the problem. Don't solve it yet, just draw that tape diagram and then come back and we'll compare our drawings. Welcome back. Does your tape diagram look similar to mine? In the tape diagram, we can see the amount of water that Shane measured, which is 457 milliliters, and we can see that Olga measured 3 times as much, or 3 units of 457. And we're looking for the value of both tapes, which is labeled here with a bracket out to the side. So now let the tape diagram speak to you. What does it tell you about how we might solve? In the tape diagram, we can see that we're looking for the value of 4 units of 457. So we can multiply 4 times 457. Now, I want to give you the chance to try using the standard algorithm on your own. In a moment, I'll ask you to pause the video and solve the problem using the standard algorithm for multiplication. And as you're solving, I want you to talk out your steps and explain what you're doing. Now, if you're not confident yet using the standard algorithm, that's okay. Just give it a try. And then you can check your work using a strategy that you're more comfortable with, like partial products or the place value discs. And once you're finished solving, don't forget to write an answer statement to answer the question of how much water did they measure altogether. Okay, so pause the video here, do the work, and I'll see you when you get back. Welcome back. Did you find that Shane and Olga measured 1,828 milliliters of water together? Let's talk through how we used the standard algorithm to solve 4 times 457. First, in the ones place, we multiplied 4 times 7 ones, which is 28 ones. We record 28 ones as 2 tens on the line and then the 8 ones. Now the tens place. 4 times 5 tens is 20 tens, plus the 2 tens that we regrouped from the ones place is 22 tens. We record 22 tens as 2 hundreds on the line and 2 tens. And we make sure to scratch off those 2 tens here because we already added them in. Now the hundreds place. 4 times 4 hundreds equals 16 hundreds, plus the 2 hundreds we regrouped from the tens makes 18 hundreds. And since we have no more numbers to multiply, we can just record the 18 hundreds right in the product. And make sure to cross off these 200s because we already added them in. And so that makes our product 1,828. Great job today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Set a timer or watch the clock for 10 minutes to work on these problems. Of course, if you have extra time, feel free to work on any of the other problems on the problem set as well. Today, we used our place value understanding to multiply 3-digit numbers by 1-digit numbers using the standard algorithm. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!